Hello everyone, welcome back to my channel again. So in this video, I'm going to solve mesh analysis problem, but with dependent sources. So from the subject name called electric circuit analysis. So dependent source. So dependent source is nothing but a source which is depending on other parameter. So there are four types of dependent sources. You can observe before going to solve. I wanted to tell about this. So you can see one is anyhow, you know that there are two sources. One is voltage source, other one is current source. But dependent voltage source and dependent current source. So voltage source, dependent voltage source is nothing but in between this diagonal will be having polarities like this plus and minus. This is dependent voltage source. Okay. Suppose if you're writing like this 4 into V1. So which means that this dependent voltage source is depending on another voltage. So that you can call this as voltage dependent voltage source. I hope you're getting now. Similarly, for the same voltage source, that's nothing but in a diagonal. So if it is having polarity, that is voltage source. So in the same voltage source, if you're having arrow mark like this is dependent current source. It is dependent current source. So it should depending on another parameter. Either it depends on other current or it depends on another voltage. Suppose if you're writing like this 4 into V1 same as it is. So this current source is depending on a V1 value. So that you can call this as voltage dependent current source. Voltage that is V1 is depending voltage dependent current source. Similarly, if you are getting like this, for example, for the same diagonal, if you're having polarities, then you can call it as dependent voltage source. If you're writing like this 4 into I1, or else the same example you can take 20 into IA, that is nothing but a voltage source, a dependent voltage source. It is depending on the value of current IA. So that I can call this as current dependent voltage source. So this voltage source is depending on the value of current IA. So that IA is flowing here. So one thing you should observe, one thing you should remember that if there is a dependent source problem, you should search where it is having that parameter. For example, 20 IA. So in this circuit, somewhere there is a IA value. So that you should check. See, IA is here. So this voltage source is depending on IA value. So that similarly, if you're having like this fourth dependent source, if there is an arrow again current source, this is dependent current source. It depends on, for example, if you're writing like this, 20 into, if it is 20 into IA, for example, same 20 into IA, it is nothing but this current source, it is depending on another current value. So that I can call this as current dependent current source. Okay. So with the help of this basics, let's solve one problem now. You can see use mesh current method or mesh analysis or loop current method to find the power delivered by dependent voltage source in the circuit shown below. So dependent voltage source is nothing but this is dependent voltage source 20 into IA. You need to find power delivered by this dependent voltage source. You know that P is given by V into I. Okay, keep that in your mind. Later we'll get to know. So here V is nothing but 20 into IA. So I is nothing but whatever the loop current that you're mentioning. Now, this circuit is having three loops. So I am marking the loop now. So here I1 is flowing and here I2 is flowing and here I3 is flowing. So giving the direction of loop along with the current. So now I'll mark the polarity. Before marking the polarity, observe now. IA, they are mentioned IA. How will write IA with respect to this? So IA, you can rewrite it as IA is given by the direction IA is downward. So you have to check this IA is flowing between two loops, that is I2 loop and I3 loop. We have to observe the loop current direction of I2 and I3. So this IA, I will write I2 is flowing downward. I can see I2 is also flowing downward. So that the same direction, IA is flowing in the same direction of I2, so that plus I2, and I3 is flowing opposite to that IA, so that I'll write minus I3. So IA is nothing but I2 minus I3. I hope you're getting this. This is equation A. So now in loop 2, I2 is flowing. Power delivered, or else power delivered by the dependent source, I will write 20 IA into I2 is flowing through the dependent source. So that IA is nothing but I2 minus I3. So you can write 20 into I2 minus I3 into I2. So you should know the value of I2 and I3 to get the value of power delivered by the dependent source. So now without wasting time, so there is a loop 1. So this is first loop, and this is second loop, and this is third loop. So now I'll apply KVL to loop 1. Apply KVL to loop 1. So you just observe here loop 1. Before that, I'll mark the polarity. Already voltage we have minus and plus. Through the resistor, it flows from plus to minus, and the direction is clockwise, so that this is plus minus, plus minus. Similarly, plus and minus. So now based on the direction of loop, mark the second polarity or else first polarity. That is up to you. I am marking second polarity, so that plus minus minus minus. So the first step, give the direction of current. Second step, mark the polarities based on the direction of current. Third step, mark the second polarity. Then you write the equation for particular loop. So now apply KVL to loop 1. So then how will write loop 1 current? So loop 1 current is nothing but plus 660 minus 5 into I1 is flowing, so that minus 5 I1. So here again in this side minus 15 into which current is flowing? I1 minus I3. I3 is flowing opposite direction. Minus 10 into I1 minus I2 equals to 0. So now I rearrange and simplify this equation to get one unknown equation. So plus 660 as it is, minus 5I1 minus 15I1 plus 15I3 minus 10I1 plus 10I2 equals to 0. So I1 you can observe minus 5 minus 15 minus 10. So 15, 5, 20, 20, 10 minus 30. So 660 minus 30 I1, 20 plus 10, 30. Okay. Plus 10 I2, I2 only 1 is there. Then only one I3 is there, that is plus 15 I3 equals to 0. So now I'll send all these into right side by keeping 660. So you can get 30 I1 minus 10 I2 minus 15 I3 equals to 660. This is equation number 1. Similarly, apply KVL to loop 2. Apply KVL to loop 2. This is loop 2 now. So now mark the polarity. Before that, you already have for voltage, that is minus and plus. So here this is plus and minus, plus and minus. Once after marking the polarities based on the direction of loop, mark the second polarity. Clockwise direction plus, clockwise minus, clockwise minus. Now we write the equation. So how will write the equation now? So for the voltage source, okay. So plus 20 into I1, sorry, IA, that is a value of voltage now. Similarly, minus 10 into I2 minus I1 minus 50 into I2 minus I3 equals to 0. So, but what is IA here? IA is nothing but I2 minus I3. I'll directly write here 20 into, so IA is nothing but I2 minus I3 from the circuit, I2 minus I3 minus 10 I2 plus 10 I1 minus 50 I2 plus 50 I3 equals to 0. I'll open this bracket also again. So now we can get here 20 I2 minus 20 I3 minus 10 I2 plus 10 I1 minus 50 I2 plus 50 I3 equals to 0. So now rearranging and simplifying this equation, you can get here only one I1 you have, I think, that is 10 I1. So I will write here plus 10 I1 I2. 20 I2 minus 10 I2 is nothing but 10 I2. 10 I2 minus 50 I2. That is nothing but minus 48. Minus 40 I2. 20 minus 10, 10, 10 minus 50. Okay. So next I3. So I to finish minus 20 plus 50. That is nothing but plus 30 I3 equals to 0. This is equation number 2. So now apply KVL to loop 3. Apply KVL to loop 3. Mark the polarity plus minus, and here it is plus and minus. Here also it is plus and minus. So now mark the second polarity again. Second polarity from clockwise minus, minus, minus. Now we write the equation minus 25 into I3 minus 50 into I3 minus I2. That is nothing but minus 50 I3 plus 50 I2. Similarly, minus 15 I3 minus I1 minus 15 I3 plus 15 I1 equals to 0. So now we simplify, only one I1 you have, I think, that is 15 I1 and I2. I2 will be having only one, I think, plus 50 I2. Then, so you have 3 I3s, 25, 40, minus 90 I3, minus 25, minus 50, that is nothing but minus 75, minus 75, minus 15, minus 90 I3 equals to 0. So this is equation number 3. Now solve equation 1, 2, 3 with the help of calculator. Then you get the value of I2, then you calculate the value of power. So A1 is 30, B1 is minus 10, C1 is minus 15, minus 15, D1 is 660. Similarly, A2 10, minus 40, 30, 0, 15, 50, minus 90, 0. So you can get I1 as I1 equals 42 amperes and I2 equals 27 amperes and I3 equals 22 amperes. So now you calculate the value of power. So now this power which is given by, I'll rewrite again here, P is nothing but V into I, dependent source, power delivered by dependent source is nothing but, V is nothing but 20 into IA, and I is nothing but I2 is flowing with respect of that. So that you can write here 20 into IA is nothing but I2 minus I3 into I2. So substitute the values of I2, I3, then you can write 20 into I2 minus I3, 27 minus 22 into I2. I2 is nothing but 27. 27. So how much you'll get? Power is nothing but. So 20 into 27 minus 22 is nothing but 5 into 27. You can get 2700 watts. This is power delivered by dependent source. So I hope you're understanding the problem. If you're having any doubts regarding this problem, feel free to write in a comment box. First, you're writing the IA from circuit, that is I2 minus I3. Why it is I2 minus I3? Because I2 is having the direction which is same as the direction of IA. So that plus I2, I3 is flowing opposite to IA, so that minus I3. Then P equals to V into I. Before that, you're applying KVL. So if you're having any doubts regarding this, feel free to write in the comment box. I hope you're understanding the problem, so that if you really like this video, please do subscribe and share maximum. Thank you.